In a casino game called mini dice, 3 dice are rolled and the numbers on the uppermost faces are noted. It costs $5 to play each game. A player chooses a number to bet on. If one of the dice shows this number, the player gets a payout of $10, which includes their £5 bet. So actually they're getting $5 winnings and their $5 back. If 2 of the dice show the number, the player gets a payout of $15, which includes the $5. So actually that's $10 winnings really. If all 3 dice show the number, the player gets a payout of $55, and that's $50 winnings and their bet back. Joe goes to the casino and plays mini dice. He decides to bet on the number 2. Let the random variable x be the number of 2's that appear on the 3 dice. So we could have none of them, 1 of them, 2 of them, and 3 of them. Now, let's think about the probability that none of his numbers shows. So that's just going to be all 3 dice not showing his number. So that's going to be 5/6 cubed. So that's 125 over 216. Now for one of them to show, that's going to be 5/6 squared multiplied by 1/6, and that 1/6 could occur in any of the 3 positions, so we need to multiply that one by 3. So that's 25 over 72. And then for 2, what we need to do is take this power down to 1 and put this power up to 2. But of course the 5/6 could occur in any of 3 positions, so that's still all good. So that's 5 over 72. And of course for 3 of them that's just going to be 1/6 cubed, which is 1 over 216, and you could check that these do add to 1. Now let's just think about the situation for Joe. In this case he loses 5. In this case he's up by 5. Remember it was 5 winnings and he gets his 5 back. In this case he's up by 10, and in this case he's up by 50. That's not part of the answer to A, but we're going to need that. And where we're going to need it is this next bit, the expected winnings. So we want the expectation. So that's going to be 125 over 216 times -5. We're going to have 25 over 72 times 5, and then we're going to have 5 over 72 times 10, and 1 over 216 times 50. So 125 over 216, multiply that by -5, and then we'll have 25 over 72, multiply that by 5, then we've got 5 over 72, that looks like a 75 there, let's make that a bit clearer. 5 over 72, and we'll multiply that one by 10, and then we've got 1 over 216, and we'll multiply that by 50. And I'm going to make that one into a decimal, so that's -0.23. and that means 23 cents loss per game in the long run. Determine the amount the casino should charge players to play the game in order to break even in the long run. Well, they're winning 23 cents per game, charging $5, so it's just simply going to be 5 take away the 0.23, giving us $4.77 per game.